Hey, 6th grade, here we are, lesson 1-9, estimating roots. Here we go. Now, estimating roots is used when you can't see any number that really works well. And here are some good examples. They have some square roots and some cube roots here. So we'll look at 28 because, I don't know anything that's 28 square root. I do know some that are close, so there's 25, because 5 times 5, and then the next one would be 6 times 6 is 36. So I look at this and I go, okay, this one, the square root would be 5, the square root would be 6. Oh, nice, 6. And 28 is closer to 25 than it is to 36. So the square root of 28 would be closer to 5 than 6. If we'd say, okay, it's going to be maybe 5.2. Now, I just double check this by doing 28 and taking the square root of that, and I do get 5.29. So on the next one, square root of 135. Now, let's see, I'm pretty sure that 11 squared is 121. So 12 squared is 144. Alright. Boy, my pen is just doing so well. So it's between 11 and 12, so it's going to be 11 point something. 135, it's 9 away from 144, it's 14 away from 121, so it's going to be closer. I'm going to say 11.65. Let's see how that looks. So if I put in 135 and take the square root, I get 11.62. So that was in the ballpark, though. Not bad. By the way, I should probably tell you this is on page 84, the ones I'm going through. Okay, 38.7. Now I know 36 is really close, so this is just has to be very close to 6.1, I would think. And if I do 38.7 square root of that, I get 6.22. Again, I'm getting in the ballpark. And that's what I'm going to want you to do when you do this is I want you to look at it first and see what you can figure out. You might have to do some calculation, multiplication, just to figure out what it might be. So let's go to the next one and show you what I mean. So this is now the cube root of 51. And let's see. 2 times 2 times 2, that's 8. 3 times 3 times 3, that's 27. 4 times 4 times 4 is 64. 4 times 4 is 16. 16 and 4 is 64. So you have a big spread. And 5 times 5 times 5 is 125. And you're going to see we have almost all of our examples covered. And 6 times 6 times 6 is not coming to me. I'm going to say 216. What do you know? 216. Alright, so I can look at all these, and I just wrote those out, and I can say, well, 51 is closest to 64, so that's 4, 4, 4. So, it's going to be 3 point, let's see, because 4, 4, 4 would be 64. 3 point, the other one was 27. 3 times 3 times 3 times 3 was 27, and this is 4 times 4 times 4 is 64. So, boy, I don't know. Let's say 3.7 and see what happens. So I'm going to put in 51 and take the cube root, and I'm going to get 3.7, almost on the dot for that one. That's pretty good. Now 200 is really close to 216. This was 555. This was 6 times 6 times 6. So I have to think it's going to be about 5.9. So again, I'm going to go 200 cube root 5.85. So pretty close, 5.85, 5.9. Last one's 95. 95 would be between 64 and 125. So it's between 4 and 5. It's about right in the middle. I'm going to say 4.5 for that one. So let's see how that goes. 95 cube root 4.56. Yep, there you go. So the idea is I want you to do some calculation stuff. Write these things out so you have those numbers. So you have 8, 27, 64, 125, 216. And then see, maybe you have to go to the next one. You've got a calculator, you can do that. Go 777, see what you get. Let's take just a look at a couple of these problems here. It says drop a tennis ball from a height of 60 meters. Time in seconds it takes for the ball to fall 60 feet is 0.25 times the square root of 60. Find 3 sets of approximations for the amount of time it will take. Then determine how long it will take for the ball to hit the ground. 3 approximations. Okay, so 60, this is a square root. So I know 49, 7 times 7. 7 times 7 is 49. 8 times 8 is 64. That's pretty close to 64 though. So they say 3 sets of approximations. I'm going to just do 7.8, which then, since that's my estimate for the square root of 60, I'd do that times 0.25. And let's see how well I did. I'm just going to put in 60 square root, see what it is. It is 7.75. And so if I multiply that times 0.25, I'm going to get 1.94. 1.94. I hope this is working. I hit the wrong button. 1.94 seconds. So that's pretty good. Yeah. 3 sets of approximations. I think you do your best, see what it is, and then multiply and see what you get. Let me check the answer on that. Yeah, that's a pretty good answer on that one. Let's look at this last one here. Number of swings back and forth of a pendulum of length L in inches each minute is 375 divided by the square root of L. And so it wants to know about how many swings will a 40-inch pendulum make each minute. So L is the length, and they're talking 40 inches. So really running out of room here. 375 over the square root of 40. Alright, well, 36, we have 36, the numbers around it, 36, 49, 6 times 6, 7 times 7. It's a little closer to 36, so I'm going to say it's going to be about 6.3. Now I like to make that approximation knowing what I know, and then I like to go see how I did. Because 40, square root of 40, is 6.3. Woohoo! 6.32 if you want to be picky. And then I just have to do 375 divided by 6.3. And we should get an answer of, boy, right around 60. It's 59.5. So it's about 60. So there you go. We'll go to the next slide and look at what I want you to do. So your assignment is page 85 to 88, 2 to 16, 22 to 32. Again, no evens, just all of them actually. Well, so you need to do the evens and the odds. A couple I wanted to show you. Number 14, if you turn over to page 86, says Amanda purchased a storage cube that has a volume of 4 cubic feet. A storage cube. So she has this storage cube, That's 4 cubic feet. 4 feet cubed. And she wants to put it on a bookshelf that is 12 inches tall. Will the cube fit? And so you have to think, if the shelf is 12 inches tall, will a 4-foot cube fit on there? So kind of need to figure out what is the length of a side. Now in a cube, every side is the same, right? I think. So that would be something times something times something. So it sounds like you're going to need to do a cube root there to see what each side would be. And there you go. Good estimate. Because the square root of 4 is 2, but the cube root of 4, it's not a perfect cube. That's that one. Then the next one is number 16. It says, find two numbers that have square roots between 7 and 8. That have square roots between 7 and 8. So I know what 7 squared is. And I know what 8 squared is. And so if I know what 8 squared is and 7 squared is, and they want two numbers that would have a square root in between those two, I'm guessing should be as easy as two numbers that would be in between these, right? I think. That's about it. The only other one I wanted to look at was number 32. Well, I think you'll do okay with that. Again, it's an estimate one. So there you go. See what you can do. Have fun. And don't just use the calculator. Use your brain. Make your estimates first. There you go.